Okay, so we're going to continue with the answers for the part B of the final, which is going to be given tomorrow. What did you guys put for number 2? What was the first step that happened here? Distributive, yeah. It is distribute or the distributive property. It's the distributive property is what you should be writing. If you don't write property, I'll be okay with that. Now, after they did the distributive property, they combined like terms, the additional like terms. I do not like using the word substitution. You can just eliminate that altogether. The next step that they did, bless you, was to add 5 to both sides. So this would have been the addition property. And then they already gave you that they did subtraction. What they did was they subtracted 6x from both sides. And then they divided by -4. So the last step was the division property. Okay. 24. The first step, of course, was given, and then they subtracted. So I'm hoping you wrote subtraction property here. I hope you, I'm sorry about the word substitution being here, since I did not do it that way at all this year. I said add or simplify, right? We did simplify for coming from step 2 to step 3. All they did was simplify it. Then they show that they are multiplying by 3s. I hope you wrote multiplication on this line. Yes, multiplication property. Is anybody confused here about why it's multiplication property? Okay, and then finally they just simplified it. I hate that word substitution. Simplified. Okay, that's what I would expect. I don't like that they even put those steps in, because like the previous proof, they didn't even have those steps in there. You just did the subtraction or the addition or the division. Okay, draw all lines of symmetry or state none. We used the following figures in 2 different ways. We asked about the 25 asked us about lines of symmetry, while the next one asks about magnitude and order. This is about what lines will cut it in half and be able to fold on that line so it maps onto itself. So how many did this thing have? The pentagon. Only 1? There's 2, 3, 4, 5. This has 5 lines of symmetry, guys. If it is a regular polygon, it will have the same number of lines of symmetry as it does sides. So this had 5 lines of symmetry. Okay, the next one has just 1. And I didn't draw that perfectly, but you probably didn't either. Okay. The next one has 1. And then this one doesn't have any. Oops. None. And the star, or if you will, it's sort of a star. What would you say on that one? How many? Well, I bet you some people have just 2. And I can't make it go through the point I wanted. I will. It has, oh, not, yes, it has 4. Okay. You know what I meant, right? Even though my lines aren't perfect. Now it's got all those pictures all over again. Deja vu. It says state which of these has rotational symmetry and find both the order and the magnitude. I have had quite a few people today asking me what this meant. That's the angle at which it rotates, the smallest angle at which it rotates onto itself. So the magnitude would be how many degrees that is to get from there to there, which is the same as that one, which is the same as that one, which is the same. So every so many degrees, it maps onto itself because this thing does have rotational symmetry. The order is the number of times it would take to rotate one chunk at a time, or to get all the way around, back up, straight up, 360. So that's, or another way to say it, how many shapes or how many corners are the same? This is 1, 2, 3, 4, 5. There are 5. This is order 5. And then to find the magnitude, you take 360 divided by the order 5, and you get 72 degrees. Okay, it's order 5, magnitude 72 degrees. Does this one have any rotational symmetry, this arrow? No, because you'd have to do a 360, and it's got to be less than 360 for it to land on itself. This one has none. No. What about this isosceles triangle? Can you spin it? Well, you can spin anything. You can spin yourself, but it doesn't mean you're going to map onto yourself with less than 360 degrees. People don't have rotational symmetry. At least they don't. They could. I don't know. You can't spin and map onto yourself. All right. So this does not have any. You can't rotate it without going 360 to get it to land on itself. If you rotate it at 180, it's just going to turn that way. Okay. No. All right, what about this thing? Does it have pieces that match in some way so that you could spin it? Would it look the same upside down as it does right side up if you went that way? Yep, this has order 2. And that means the magnitude is 360 divided by 2, so you should have magnitude 180 degrees. Okay, what is the order of the star thing? Okay, order 4. How many degrees does it take for this point to get to that point? Okay, so that's order 4. This is Y. And the magnitude is 90. Okay, and then last couple of things here. Oh, 27. Did you need me to stay back here? Okay. We had some trouble with this on the last unit test. This was one of the most missed types of questions. When a figure is enlarged or reduced, it is a dilation. That was missed a lot as to what transformation it was. You guys wrote it was a reduction or an enlargement. A lot of people did. Well, that's not what the question was. It said, what's the transformation? Now, this one's saying, it is asking if this dilation, which is what the transformation is called, is a reduction or an enlargement. Well, how do you know? A prime is the new one, isn't it? All right, so this one's the image, and this is the pre-image. So you do image divided by pre-image to get the scale factor, which is like saying the new over the old. All right, so we're going to figure this out. So if you went from this bigger triangle to the smaller triangle, it was clearly a reduction. Okay, and they want to know by how much. That's what scale factor is. So I would say, where is point A? It is at 0, 3. And point A prime is now at 0, 1. With me? You can check any of these. C is at 3, negative 3. C prime is at 1, negative 1. B is at negative 3, negative 3. Oopsie, weird looking 3. And B prime is at negative 1, negative 1. What's happened to these points? They got smaller by how many times? 2? 3. So I would just take the easiest pair. The new over the old would be 1/3. 1 over 3. You could do negative 3 over negative 1 over negative 3. Any of those compared gives you 1/3 for the scale factor. If it had been an enlargement and the primes were on here as opposed to here, it would have been a scale factor of 3 times. You multiply the points by the scale factor. So if you were going to multiply 1/3 times -3, you would get -1, -1, like dividing by 3. 28 says to classify by the number of sides. Now, I'm going to be a little sarcastic here in that I literally got answers on the chapter test where this was, and people wrote 5. We are not in 2nd grade where you can count up the little segments, guys. Come on. I do not want to know that it's 5 sides. Classify it by its sides doesn't mean to tell me how many sides it has. It tells you to give me the name of it. Everybody here, I mean, sorry, but that's not enough of a challenge in 10th grade to go 1, 2, 3, 4, 5. Hello, right? Come on. So what's the name of a 5-sided figure? We got special names for them. That's a pentagon, right? And I had you learn up to, well, we did talk about up to 12 sides. And then after that, we said just do the number of sides dash GON. Right, but you should know triangle, quadrilateral, pentagon, 6 sides hexagon, 7 heptagon, 8 sides octagon, 9 sides nonagon, 10 sides decagon. Okay, and I didn't really go over the undecagon or unidecagon, which is 11, and then dodecagon is 12. We did talk about dodecagon. What's this thing? How many sides? It has 8 sides, so it's called an octagon. Okay, so please do not tell me how many sides it has. Give me the name. All right, and then convex, concave. I kind of discussed with you what the formal definition was, which you probably do not remember. What I would think you probably remember is that concave is dented in. Is that what you remember? Convex is not dented in. Okay, but the formal definition is a figure is convex if no diagonal contains any points outside of the polygon. Okay, this one's convex because every diagonal contains points only inside the polygon. This one is concave because this diagonal right here would contain points outside the polygon. All right, I know what you're going to remember. You're going to say this one's dented, so it's the concave. And this one's not dented, so this one's convex. Is that an accurate assessment? All right, good enough. However you remember it. I am not going to test you on the formal definition. Okay, this was the end of part B, which is what the final exams part is on tomorrow. I'd like you to take now your part A and start working on it.